Center, where he is now director. And Bill Hoesch is our speaker. He's received a bachelor's degree in geology from the University of Colorado, a master's in science from the Institute for Creation Research Graduate School. That's back when it was in San Diego. He served for 17 years at the Institute for Creation Research and has been an educator ever since, including a year of missionary service in China, leading field adventures, including to the Grand Canyon. So let's welcome our speaker this morning, Bill Hoesch. Bill?
Testing one. Hello, hello. We got power? Can you hear me? Thank you, Steve. Thank you for DSA. Thank you for Mark Nelson. Thank you for Rick and Sylvia and Stan and the people here. How long has this been? How many years has DSA been running? 1990. Yeah. I think that's back when dinosaurs roamed the earth. Okay. All right, yeah. Well, it's really cool to hear. How about we open with a word of prayer? We're going to talk about dinosaurs today, and I'd like to ask the Lord's help. Almighty Father in heaven, we praise you and thank you for the Lord Jesus Christ and the forgiveness of sin. And we thank you for the life that you give to us. Now, Lord, make your life real as we share on just the topics of your creation, about the bones and the things you left in the earth. I pray that you give us understanding and insight along the way. In Jesus' name we pray. Amen. All right. I am the director at the Mount St. Helens Creation Center, and I'd like to invite everybody out there. We really do have an amazing dinosaur and fossil museum in one section of the center, and we've got some of the most informative displays anywhere, even though it's pretty basic on the pre-eruption, the eruption of Mount St. Helens, and what kind of lessons you learn from a volcano like that. And we also do our field adventures. We're out there 2 to 3 times a week, full day trips out to Mount St. Helens. We do that in the summer months. We're getting ready to start. We're already booking up with people beginning in middle of May, and we go through mid-October. And we just completed our Creation Worldview class. We met with, we gave certificates to 45 kids this last week, for completing 20 weeks of sessions, 2 hours each session, right through the winter months on creation science, basic creation science. And wow, we had a good time. And you have fun with kids. You gotta insert a little fun with them. You have to have activities, and so we have them blowing up things and swinging across the room on ape swings, and you got to have a little bit of fun, right? So that was that, and that's kind of what we do. And I'd like to, I just really thank God for the DSA, and I thank God for people like J.D. Mitchell, who, he's brought all the dinosaur things and the fossils into the Creation Center. And it really is an artistic, go ahead, yeah. And some outstanding artists who completed the archways and the coloring and I brag to people, it's a work of art in there. But today I want to talk to you about dinosaur graveyards, which means I'm not going to be focusing much on the vertebrate paleontology of dinosaurs, because we've all heard about that. We know what kind of food they ate. We know what kind of, there's stories about their migration and stories about this and stories about that and the type of dentition they had and what kind of brains they had and the bones and the shapes and all that and the articulation of the bones and how heavy they were and how long they were. That's all very interesting. But I'm a geologist. I like to talk about the rocks that they're buried in. That's the thing that gets my attention. And so I'd like to just walk you through some of the things that kind of make me jump up and scream, because it seems like the vertebrate paleontologists have the microphone and they talk about the bones and everything. Who's talking about the layers that the bones are found in? Those are interesting to me. So I'd like to just give you a little outline here. I'd like to begin with a 4-point outline, right? Number one, I want to raise some dumb questions. Now, they sound like dumb questions only because nobody's asking them, or not many people are asking them, it seems. And then I want to look at a few case studies of some of the premier dinosaur beds in the western U.S. And number three, a word about mud. I want to talk about mud. And number four, I want to think about a biblical view of Earth history, of dinosaur history, and see if we have a coherent picture or is it incoherent. I am happy to admit there's lots of mysteries about the geologic record when it comes to dinosaurs, but I do not hesitate to defend a biblical young Earth creationist view because I think it is very defendable, a lot easier to defend than the evolutionary worldview is, logically speaking. And of course, biblically speaking, we have all of good reasons to trust the Word of God. Okay, and one of the questions I get at the Creation Center is this one. You got your dinosaur and fossil museum over here, and then you got your display on Mount St. Helens over here. What on earth is the connection? What is the connection between dinosaurs and Mount St. Helens? Right? It's a good question, right? And my answer is mud. Now I think somebody mentioned somebody's got a nickname now named Mud here. Who's Mud? Yeah, I want to meet you. Yeah. Anyway, I'm going to show just a very brief video clip of a mud flow at Mount St. Helens in 1980. Now, you know what happens when you have a mountain spewing hot volcanic ash, a mountain that was totally packed with snow and ice, including glacial ice at the time. You get a mixture called mud, and it's like wet concrete. And if you can picture porridge spilling down the valleys like the North Fork of the Toutle River, you have a pretty good picture of what's going on. And so I like to connect that with dinosaurs. So I'm going to just show you a little video clip I've got of the mud that was roaring down the North Fork of the Toutle River. It's just a little clip here. There's a house that's colliding with a bridge there, and I don't think that one made it. And things that don't ordinarily float in dense mud. Look at that. I guess you could call those mobile homes. Rocks, boulders, cars, trees, logs, all of it were stacked up and demolished by mud. And so that's the connection, that's the short answer of my connecting point between dinosaurs and a volcano like Mount St. Helens. And we'll get to that, I'll develop that some more. But I'd like to begin just first with some dumb questions, right? And number one, I just got some questions. How come the sauropod skeletons are almost always found headless? It's the rule rather than the exception, did you know? They hardly ever find the skulls attached to those skeletons. Sometimes you have a fully articulated Apatosaurus skeleton and the skull is missing. In fact, it was a big embarrassment in the history of paleontology when they had to mount a skeleton in some of the big museums back east and they couldn't find a skull to put on it. The curator is looking at it and says, "It looks beautiful. We got this big hall about the size of this room filled with an Apatosaurus skeleton, but no skull. Go down there in the basement, find a skull, and put on that thing, will you?" And that's how they developed Brontosaurus. Brontosaurus was the headless dinosaur. Okay, anyway, it's really, it's just, I use that just to remind people that these things are always found headless. And that's why it's a problem to identify what the skull looked like, what skull belonged to what skeleton. Most people don't know that. Number two, why do most dinosaur sites look like a train wreck of skeletons? You go to Dinosaur National Monument and you tell me what that thing looks like. I was there first time, I guess it was 1980 or so, 1990 maybe, and a couple of people from the Midwest were standing there. They looked like a retired couple, and they're looking at that wall, the famous wall of dinosaurs up on there, and they're saying, "What do you think of this one, John?" "Well, I don't know, Mary. Looks to me like a big flood came through here." they're talking that way, and they're not, and I'm a creationist, I'm listening, I'm overhearing their talk, you know. Anyway, it was interesting to see that. That's the first impression you get. The most glaring impression you get is one of utter catastrophe, and yet everybody talks about Jurassic Park as if it was a park in a wonderful little world. Number 3, why is the so-called death pose, the opistotonic death pose, so common in dinosaur skeletons? They're always found with their necks arched over, not always, but on a large number of cases. It is a horrific pose of death. It suggests, and we'll talk about that in a minute, it suggests death by asphyxiation, perhaps drowning. That gets my attention. Number 4, why all the odd bedfellows buried with dinosaurs? In the same layers with dinosaurs, we find things like clams, mammals, fish, birds, marine invertebrates. Am I to believe that this is an ancient ecosystem? That marine creatures lived with dinosaurs in the same environment? They always want to tell you a story about how this layer represents an environment. Maybe this was a sluggish river, or maybe this was a levee break on the riverbank, or maybe this was a floodplain or something. I think they're all got it wrong. I think there's something bigger than that involved. Number 5, what's with all the mummified dinosaurs? That's a mummified ankylosaur. And they find not just the bones, but look at that. They find the skin, they find the eye sockets. They even poke around in its tummy to find out what its last meal was. Imagine that. Something happened to these dinosaurs that I just am not getting the full picture on. And number 6, if these things were slow buried 70 million plus years ago, why do we see all the soft tissue inside their bones? You know, they moved a T-Rex bone back to the lab in the year around 2000, 2005, something like that. Mary Schweitzer, she moved it back to the lab, and they had to break the dinosaur bone to get it in the helicopter, I guess. And when they got the broken piece back in the lab, somebody looked at, hey, what's that thing? Looks like a rubber band sticking out of the middle of the bone. And somebody said, it's not a rubber band. It's a blood vessel that you could pull with little tweezers, right? Inside hard dinosaur bone, soft tissue, and with red corpuscles inside there, and with nerve tissue. Since then they found that. They found collagen, different types of protein you can stretch. And not only that, but one of the dirty little secrets is that most dinosaur bones are not mineralized. They're not petrified. They're actual bone material. They're actual bone material. And the latest find by Dr. Mark Armitage, I like to point to. He just published that last year in Microscopy Today. He reported blood clots inside more than one species of dinosaur. Inside the bone is an abundance of hemoglobin kind of blood. It looks like blood clots, and he's identifying it that. And the thing to underline there is it's the kind of blood clots that only form in drowning victims. And people who are emergency personnel, they know about this, that if a drowning victim is pulled out of the river and they're near death, first thing they got to give them is anticoagulant, because when the body goes into shock, it's my understanding that somehow the whole body coagulates, and you have to get that blood going again. That's interesting to me. These are things that are not being, you just don't hear this being talked about. And number 7, how come there's measurable carbon-14 in dinosaur bone? If you know anything about radiocarbon, you know that it can't possibly exist in objects more than 100,000 years in age, and yet these bones are claimed to be 70 million years in age. Either something is wrong with the C14 dating method, or else these things are not nearly as old as they claim to be. And right now they want to have the scientific community, they recognize this as like the soft tissue. It's just one of those anomalies, and someday we'll come back and balance the books. We don't have an answer to that today. But someday we'll come back to that. And number 8, I mentioned that. Why are the bones so frequently not replaced or permineralized? They're actual bone tissue. That's interesting. Oh, and one more thing about the C14. They've been finding this in ancient coal, ancient diamonds even. Now, diamond is a type of mineral lattice that excludes contamination. So you cannot say there's contamination inside the lattice of a diamond. And yet there's measurable C14 in there, indicating that thing, even though it's claimed to be over 500 million years in age, a lot of your diamonds are, maybe much younger. And then number 9, how come reptile trackways are almost never found with the makers of the tracks, but they're always in older strata? Now this is really peculiar, and it really seems to be a genuine trend that when they find trackways in the strata of dinosaurs or reptiles, as this picture shows, the makers of the track always appear later or in strata above where the tracks appear. What is that telling us something? These are just some of the dumb questions that I wonder about when I look at and think about dinosaurs. A couple more, we got 12 more, this is it, yeah. And what's going on with gastroliths? These stones that are found inside the stomach cavity of some dinosaurs, they're rounded and they look like they were carried in the stomach. Some of them are a lot of stones inside the tummy. And what's going on there? Some of the stones they've identified are exotic. They came from a couple thousand miles away, and they find them inside. And because of that, some are claiming today that dinosaurs are long-distance migrators, at least some of the big sauropods. They traipse across the whole continent. I wonder about that, because a lot of the rounded stones inside the stomach of these things are a lot like the individual stones floating in the mud rock around the dinosaurs as well. Was the whole package transported long distance? That's what I'd like to know. And then number 11, what about dragons? Here are just some of the questions I have, right? Why are there common stories from every culture, including engravings and accounts from historians? Were they all legend or myth? Are we, in our modern age, we tend to think that dragons, well, that's folklore and legend, and we can all dismiss that as part of a different age when people love to tell stories, right? Well, maybe there's something more to it. There's too many common features in these stories that gets my attention. And many of them are written in historical narrative. On this place, in this date, I saw this creature, including people like Marco Polo in his journals, including Herodotus, the ancient historian, wrote about seeing these creatures. And countless ones like this, including right on up into the middle centuries in Europe, in England and so on, King George slaying the dragon. What's going on with these stories? Number 12, these are just some of the dumb questions. We're almost done here. What does it take to bury a large sauropod like this Brachiosaurus in Portugal? Now, some of these things were, I don't know if you know this, but some of the big sauropods coming out in recent years are truly enormous. They would have made the so-called Brontosaurus look rather wimpy. Some of these things are gigantic. And no doubt a lot of them, when they're lying prone in the strata, when they find them like that, they have a girth probably 15 feet or more. What does it take to bury a creature like that? You have to bury it fast enough to keep it from rotting, don't you? Because the bones and all will rot if you give them time. Like a whale on the beach, right? There's a whale on the beach in Florida. That's a substantial mass. How come those things are not turning into fossils today? How come we don't have whale fossils forming on our beaches? There's been lots of beached whales down through the centuries. We don't see a lot of that. How come? Well, you all know the answer. The bacteria and the animals and the scavengers, they eat those things up in quick order, and the waves break them apart. We don't have fossilization happening like that, do we? This is a peculiar thing. These are one of my dumb questions, right? Now, picture this thing. This is Dreadnoughtus. I don't know if you've ever heard of this one. The recent, last 10 years or so, they found enormous, but that's considered to be the largest now of the sauropods. and I think it comes from South America. Anyway, what would it take to bury a thing like that so you get its skeleton preserved? What does it take to do it? You think about that. That one is called Dreadnoughtus, and this one is, I've got another one, specimen here. This one is called Donutus. And it's 4.1 inches from head to tail. And, okay, sorry. It's my crazy sense of humor, okay. But let's think about what it would take to bury one of these things. Think about this. If we just look at the duration of the Mesozoic, the standard numbers that people throw around is that the Mesozoic lasted for 186 million years. And I'm here to tell you that most geologists don't even ponder what that means. People throw around big numbers like that the same way politicians throw around their trillions, right? The thickness of the Mesozoic in the western interior, let's just use that as an average on the order of 3,000 feet. Some places thicker, some places thinner, that's okay. That would imply an average rate of accumulation of 0.00491 millimeters per year. Now you think about that number. 1/100th of a millimeter, well goodness, that's thicker than your hair, right? That's the average rate of sedimentation, and you're going to bury a dinosaur like that? Obviously not, right? In fact, at this rate, it would take 500,000 years to bury a sauropod with a 15-foot girth on it, 15-foot diameter. Rates that slow cannot qualify as, quote, uniformitarian. They don't even qualify. Why? Because the dust on your refrigerator accumulates faster than that, way faster than that, orders of magnitude probably, at least an order of magnitude faster. There's no place on Earth where sedimentation accumulates at that rate, nowhere. There's always something accumulating somewhere that's a greater rate than that. So I want to let's look at the overall fossil record for just a minute, and I want to think about this just a little further, press it a little more. And here we've got the so-called geologic age chart. I hope you can read my writing there. And there you got the age of the reptiles, so-called 186 million years in duration, right? And I want to just give you, here we got, like I just said, the average rate of sedimentation would have been less than 5/100ths of a millimeter per year, if we assume that. Nobody believes this. Geologists do not believe that that is the rate of sedimentation. They all believe it was sudden bursts of sedimentation that built up the record, separated by long periods of boredom, you understand? So you had a burst of sedimentation that buried this dinosaur, and then you had a few million years, and then another burst, and so on. That's the way they think about this. So most would say the sediment arrived in rapid bursts separated by vast times. Assuming, let's just go ahead and assume that you had 300 such rapid bursts to build up most of the Mesozoic record. The time gaps between each one of those would have had to have been over 500,000 years each. Do we see evidence of time gaps like that in the rock? There should be evidence if it's true. I should be able to find unconformities or a barrier or a boundary between layers that testifies of vast periods of time. Do we see that kind of thing? No, we don't. Think about this. It probably took less than 500,000 years to generate the relief we see on the Earth's surface today, including Mount Everest, including the highs and the lows, thousands of feet of elevation difference between the valleys and the mountains. You would think that there'd be that kind of relief on the surface of the boundaries between the layers within the Mesozoic strata. What do we see? We see unconformities there for sure, but they're absolutely trivial compared to that. I don't see the evidence for millions of years in between those layers. I don't see the evidence in the layers themselves, in the dinosaurs and the stuff that's in them. So I would say this, here's a radical suggestion. Most geologists don't really believe the time scale they give allegiance to. They don't really think it through. And if you're a geologist here today, I'm here to tell you, you need to do some thinking, right? I got challenged. You know, when I was a new believer, I got challenged by a geologist who said, you know, the main reason you studied geology, let's face it, is probably you flunked math. That's why you went into geology. I think JD's smiling. He's an engineer, right? He knows that. Yeah, and then the other thing he said was, he got under my skin this way, right? He said, chances are the second reason you like geology is because, not because you like science, but because you like to philosophize about the past. Ooh, he got under my skin. He's the guy who changed me from being an evolutionist to a creationist. That was like 40 years ago in Houston, Texas. Anyway, I got off. I don't know how I got on that. So there's just some dumb questions I wanted to leave with you. And dumb because they're not really being asked today. How come we don't hear about those things? How come we always hear about Jurassic Park and all this kind of stuff? Well, let me just give you a few things. Sorry, I don't have these laid out nicely. So the vertebrate paleontologists, they report on the dentition, phylogeny, behavior, etc. Frankly, those things bore me. Compared to the bigger questions that I just raised, those things are boring. And as a non-expert, I dare to make a few generalizations. Do I have all the answers? No, I don't. I'd like to know the answers regarding the trackways in the Mesozoic. How come we have trackways high up in the sedimentary rock section when everything should have been dead at that point? I don't have a full answer for that. I'm happy to tell you that. How come it seems like in certain layers, it appears that bones laid out for a time enough so that there was desiccation of the bone, and in some cases scavenging on the bone? I don't know about that. I wouldn't expect to see that in a flood model. But anyway, the thing I'd like to emphasize is that almost everything about these so-called dinosaur graveyards is extreme. Were they really slow buried more than 65 million years ago in sluggish river channels, levee breaks, etc.? Or are we trying to put a round peg in a square hole? That's what I want to know. So I think the full story of these creatures is yet to be told, but I don't see any reason to step away from a biblical view of Earth history. And I'm going to summarize with that and we get along. So let's keep moving. I hope that was interesting. Anyway, let's go to some case examples, some case studies. I want to look at Dinosaur National Monument. I think it's the world's finest in situ display of dinosaur bones anywhere in the world. And number two, some of the other so-called dinosaur graveyards, including the Hell Creek Formation, Chinle, and one in China called Yixian Formation. And when we do this, we're going to look at some of the premier beds in the Triassic and the Jurassic and the Cretaceous. In other words, these are the rule, not the exception, that I'm going to point to. This is the premier dinosaur beds. Are there some common themes? I want to give you 7 observations, and then I want to try to bring you towards a biblical interpretation. When we look at the western U.S., the western interior states of the United States, we call that dinosaur country, right? And in there we've got layers, individual layers within the stratigraphic section that extend over a vast area. The Morrison Formation is one of them. Extends from Canada nearly to Mexico. It's a big, big area. It's one layer, hundreds or in places 1,000 or more feet thick. It's enormous, and it is one of the big storehouses of dinosaur beds. The Hell Creek Formation in Montana and the Dakotas. And then I want to talk a little bit about the Chinle Formation, one section of the Chinle. The Chinle is much bigger than that, but one section of it where we find some dinosaurs there. And one more as well, just for fun, I'm going to bring in one from China there, the Yixian Formation in China, and I'll mention that very briefly. But let's look at some of these things in particular. Dinosaur National Monument, this is the Quarry Visitor Center. It's perched on tilted strata of the Morrison Formation on the flanks of the Uinta Mountains. And inside that shed-looking structure there is the famous wall. And the wall looks like that. It's 150 feet long, and it's 100 feet, or I don't know, 40 feet tall, something like that. And in that it looks like a train wreck of dinosaur bones. It's the one I mentioned. In the wall, nearly complete, Allosaurus, Apatosaurus, Barosaurus, Camarasaurus, Comptosaurus, Diplodocus, Dryosaurus, and Stegosaurus. And specimens from that wall have been extracted and stand in some of the world's foremost museums around the world. About 120 individual dinosaurs were recognized, and about 1,600 individual bones stand out in relief on the wall. So you can walk past these bones, in some places touch them, and it's a pretty amazing thing to see. It's telling you some kind of a story. And if you read the exhibits in the walls in the monument there, this was a sluggish river, something like that, and that buried these dinosaur bones. Well, I've got some problems with that idea. Anyway, these are the kind of dinosaurs they find in there, and this is the geology of the strata. It's called that 400-foot thick layer is called the brushy basin member of the Morrison Formation, and in it is the quarry sandstone, and in the quarry sandstone is where the dinosaurs are found. And it's got a colorful story behind it. The year is 1909, and this guy here, Earl Douglas. Earl Douglas was a dinosaur hunter in the year 1909, and he was traipsing around the western interior because his boss, whose name was Andrew Carnegie, in the museum in Pittsburgh, he said, you know, I've got this big haul, and I hear they've been finding dinosaurs, these big sauropods in the western United States. I want you to go out there and find one for me and put it in the haul, would you? And so Earl Douglas was a man on a mission, and sure enough, after traipsing around for a period of time, he came across this place in Utah, and what did he see? Brontosaurus vertebrae protruding from the top of this ridge. And sure enough, he began digging, and it took a long time because the rock was hard, and but he was pulling through all the dang Stegosaurus and the other bones that were getting in the way to reach that skeleton. It took, I think, a couple of years to excavate it, but today it stands in the Carnegie Museum. And when they put that thing up, they first mounted it up there. Somebody said, hey, we got a problem because the skeleton looks beautiful. It fits in this big hall, but where's the skull? Oh, we didn't find the skull. And it was more complicated than this, but essentially something like this happened where somebody said, go down the basement and put a skull on that thing, will you? And they found a Camarasaurus skull to put on top, and that's how Brontosaurus was born. And Brontosaurus was the dinosaur that never was. Now, technically, they've revived the name and so on, but it was one of the biggest embarrassments in the history of paleontology that thing stood in the leading museums, and we got Sinclair the dinosaur, and we got all the dinosaur cartoons and so on that are based on Brontosaurus. Brontosaurus, today we know that and this was corrected in 1980, today we know that the proper skull on the skeleton of Apatosaurus was a long snout. It's completely different from the blunt-nosed look of Camarasaurus. They had the wrong skull on that thing. And it just helps to underline that these things are almost always found headless. We just got, by the way, we just got a brand new Camarasaurus skull in our Dinosaur and Fossil Museum. So you got to come and see it. Yeah. It looks beautiful. It's a replica, of course. It would take too much to get our own, but it's really cool. I like it. Okay, so yeah. That's what the wall looks like today. Oh, sorry, there it is. I visited there in 2008, and I got to meet Dan Chur, the vertebrate paleontologist, and I was there to kind of pick his brain. He's a secular paleontologist, and he was telling me all this and that, and I went through I kind of rated their files on information because I wanted to write an article with Steve Austin on it. But this is the data that you get. Here is the data that they mined from to create Jurassic Park movies. And this is the data from which we get a lot of artists' work like this of Brontosaurus. Brontosaurus was the dinosaur that never was. I like to say, again, technically they revived the name, but that's okay. But Brontosaurus died in the 1970s. Apatosaurus is the name that applies, right? And he's got, so the snub-nosed, the big snub-nosed dinosaur has been put to rest. And almost all the geologists familiar with the Morrison Formation, they question different aspects of that picture. That picture stands in the Yale Peabody Museum. It's a big mural. And Rudolf Zallinger got the information from that picture from the world's leading paleontologists at the time. This is what they think the age of dinosaurs looked like. They think it was a swamp because the big sauropods, of course, were too heavy to walk on their own. They must have buoyed their bodies in the waters of the swamp, and they ate vegetation. And so we get the cover of Life magazine that looked like that. That was taken from the same mural. We get the Age of Reptiles stamp in 1970. Look at that. There's Brontosaurus there. And there's 1993, Jurassic Park came out, the first version. Man, that's 1993. And, but the idea of the head was wrong. The swamp was wrong. Today they think they wandered around in a semi-arid desert. The buoyancy support idea is completely garbage. The idea of them being kind of slothful and stupid creatures has been rejected, and many people think they were hot-blooded, but that's up for debate. And the environment is certainly questioned. All that picture came from the dinosaur wall. They had no other data. That was the main source of data, was the wall that I showed you. The age of the thing has been debated and kicked around so much. So you got a fictional animal in the fictional waters of a fictional swamp during a fictional age. What do you make of this? This was concocted not by Hollywood, this story. This was concocted by the leading scientific people of the time. And it's today we know it's a totally false picture. What is the age of the Morrison Formation? We've got a lot of age uneasiness going on here. The age of the Morrison has been the chief point of dispute for decades, says William Stokes, 1944. 1998, one of the significant unresolved problems related to the Morrison Formation is its age, both chronostratigraphically and biostratigraphically, koalas. These guys, Anderson and Lucas, these are the big names now. Jurassic or Cretaceous, the question has not been satisfactorily resolved. It was still up in the air whether these were actually Jurassic or maybe they should change Jurassic Park to Cretaceous Park, I don't know. The Upper Brushy Basin member contains many altered volcanic ash beds with datable phenocrysts, so it's totally datable for radioisotope dating, but they never seem to find the right age for the thing. What is the true age of the dinosaur deposit? Is it 135 million? That was in 1986. Or was it 148 million in 1992? Or was it 153 million according to 1991? Or it was none of the above? I suspect it was none of the above. There's too much picking and choosing that goes on with these dating methods. And the vertebrate paleontology people really get upset over the geologists. They say, how come you can't give us better dates than what you give us? We want to figure out how these things evolved, and we need to put a peg in the wall to figure out how this one supposedly evolved into the next one. And the poor geologists they've got nothing to say. But this is volcanic mud rock. It's very suitable theoretically for dating purposes. They should be able to get dates. It's very interesting how they've not. Dodson and Baker, 1980, speaking of the Morrison Formation in general, have they found evolutionary trends among the dinosaurs? The fossil content is uniform from top to bottom. It's admitted there are no evolutionary trends within the Morrison Formation. It's a major section of rock without any evolution in it. And this is true of the dinosaurs in general. quote, we failed to find any convincing evidence of evolution at the generic level within the Morrison Formation, and that comes from Dodson and Backer, 1980. These are some of the heavyweights at the time. They were not flakes. And then I asked, what is the most abundant fossil in the quarry? In the dinosaur quarry, the famous Wallet Dinosaur National Monument, which species of dinosaur is the most abundant? Which ones were really populated? What kind of animal was the most abundant? Well, it was clams, right? Clams were the dominant fossil in that layer. What are clams doing buried with dinosaur bones? They find these unio clams like this, and it's, by the way, the clams are identical to modern unio clams, a freshwater clam, we think. Anyway, we know something about these clams. They require clear, non-turbid water. They require large rivers and fish for their life cycle to continue. And they're all have been transported. None of those clams were happy clams that lived in that layer. They were all buried. And some of the clams in the Morrison Formation elsewhere are buried, entire bed of them, where they're buried with both valves in a closed condition, indicating what? They were probably buried to death. They were very unhappy clams when they landed, all right? And so, articulated clams. Yeah, so there we go. So instead of Dinosaur National Monument, I suggest they give it a different name. It ought to be called Clam National Monument. But I don't think anybody would want to go there. Who wants to see a bunch of boring clams in the rock layer? Right? I don't think they're going to follow my advice, no. Let's think about the layer that they're found in just for a moment. That's called the brushy basin member, like I said, of the Morrison Formation. Its thickness is about 140 meters. Claimed to have been deposited in about 1 million years. And I'd like to ask the question, is there anything about the strata inside that brushy basin member that even suggests slow accumulation of strata at a rate of, on that, if it took 1 million years, it would be a accumulation on the order of much faster than the average Mesozoic, 0.143 millimeters per year. All right, that's about how, that's not nearly as fast as your fingernail grows. All right, is there any indication that it really accumulated at such slow rate? Nothing. There's nothing in there. So the brushy basin member looks like that in cross section. It's tilted again because of the uplift of the Uinta Mountains. Normally these layers are flat lying. In other places it looks like this. So the brushy basin of the Morrison Formation tends to erode in badlands. Why do they call it badlands? Because no plants can get a foothold in it. And how come the plants don't grow on the surface of these badlands? Well, it's because there's it's that type of volcanic ash, the clay that is buried with them, it shrinks and swells in the presence of water, and the plants can't get a foothold in it. And so it gives that kind of weathering look like that, and so it's it's very interesting. So where did all the volcanic ash come from in that deposit? You know, that layer, the brushy basin member of the Morrison Formation, 140 meters, which is roughly 400 feet in thickness, it is more than 50% of it is made of Montmorillonite type clays. That doesn't mean anything to you, but that means it was a volcanic clay of the same type that came off of Mount St. Helens. The same kind of mud that buried the logs and the houses and boulders and so on in the aftermath of Mount St. Helens is the same kind of deposit that buried the dinosaurs. No question about it. And in fact, the mineralogy is quite similar in its clay composition. Volcanic ash breaks down readily to mud, and the mud is a expansive mud that forms badlands like this. So you've got more than 50% of the material in the brushy basin member composed of explosive volcanic type of deposits. So that's pretty amazing. Where did all the volcanic material come from? Have we found the volcano that produced this massive amount of stuff? No one's found this, but we do know that probably in California somewhere on the edge of the continent, there was volcanism on a scale, maybe during the flood, I suspect it was, on a scale that was off the charts in terms of intensity. I would expect that in a plate tectonic catastrophic kind of model. All right? So badlands, expansive clays. Okay, I just said that. So I picture airborne ash settling into water in some cases, forming an ash water suspension that flowed like wet concrete. And that's what transported animals and plants before coming to rest. We're talking volcanism on an unprecedented scale. Where those dinosaurs lived, where did those clams originally live? Nobody has any clue where they lived. They're all transported. There's nothing in there that's in situ. Nothing in there that was in a happy environment at the time. Everything was transported. And that's the nature of the entire sedimentary rock record. It's all transported. There's nothing in there that is in situ that truly is hands down, you can say that. So I think you can say that volcanism on a giant scale is needed to explain these things. These are just some of the things that get my attention. So the logs that took out the bridge at Mount St. Helens there, picture that same kind of mud moving dinosaurs, floating them along in mud, right? Yeah. So in that bed with the dinosaurs, we see clams, we see pebbles, we see snails, logs, wood fragments, all transported in a single event. By the way, the amount of wood and plant material is minuscule. In fact, they don't know where they could have possibly found enough food for all these big sauropods, because very little plant material is found in there. Both normal and reverse grading of beds is found, indicating that's the same kind of layering you get from the mud flows at Mount St. Helens. And we know where they got buried. We don't know where they once lived. We got to dispel that image of a calm and serene park-like environment for this deposit. It was anything but that. It is unbelievable that that continues to me. And I'm just the guy who's asking dumb questions. I'm not a vertebrate paleontologist, so forgive me. And some of you are going to jump on me for being perhaps inaccurate in my generalizations, but bear with me. The snails that are found in there, the gastropods rather, that are found in the deposit, they only live, they're identical with modern forms, and they only live in non-turbid water. Any kind of clay suspension water would kill those things. And yet they're buried in that. I would submit they did not live in that deposit. They got transported there. The grains and pebbles were all transported. It looks like a mud type of deposit like that. That's a picture there of the mud that was carried with it, including pebbles and so on. And we see the famous, this is an Allosaurus at the Dinosaur National Monument. Notice the skull is pictured there. It was found in that twisted up position with the skull separated from the body. And what is the business with it? Here's one expert, a couple of experts talking about, including Kevin Padian, who's one of the big names in vertebrate paleontology. He said this: the apostatonic posture is the result of death throes, not post-mortem processes. An individual so afflicted assumed the posture before death, not afterward. They used to say that this was rigor mortis. In other words, the body, it curled up after the thing died. Now they say it happened before death. Something happened to shock the creature, go into that arched position, and it got preserved that way in the rocks. So the epistotonic posture tells us more about the circumstances surrounding death than about what happened after death. Isn't that interesting? Something happened that was catastrophic to these creatures, something extreme. Let's keep going. I'm still talking about Dinosaur National Monument. Believe me, the other ones go a lot quicker than this, so bear with me. Yeah. So we're looking at the wall there, and think about the food requirements of an Apatosaurus. The thing probably had to eat like 3.5 tons a day, all right? In other words, where are you going to get the food for this thing? It's not found in the brushy basin of the Morrison Formation. Scant amounts of wood and plant debris are found in there. In fact, they say plant fossils are rare in the Morrison Formation. Parrish, 2004. Identifiable plant fragments are practically non-existent, said White. The Morrison in Montana is practically barren of plant fossils throughout most of its sequence. The absence of evidence for abundant plant life in the form of coal beds and organic rich clays, or even fossil pollen and spores, in much of the Morrison is puzzling. Yeah, it ought to be puzzling. Something's wrong with that picture, that this was an ancient environment. It looks like it was a catastrophic deposit. Through and through, everything about that thing is extreme. A couple more ones to talk about. The Hell Creek Formation is among the world's richest dinosaur beds. It's about 100 meters thick, and it's in the Cretaceous, and it's got triceratops, mummified hadrosaurs, the finest T-Rex specimens, and soft tissue abounding in it. And it's also buried with marine fossils, lots of them, including ammonites, sharks, rays, plankton. All that stuff is mixed in with it. Are these dinosaurs going for a swim in the ocean? Is that how they got there? Or did they get buried with strange bedfellows like that? Something happened that was extreme. And it also is dominated by badlands. In other words, it's got swelling clays, the volcanic rich clays there as well, and it looks like this. So the biggest T-Rex found came out of the Hell Creek Formation. But also you got fossil plants in this particular layer, well-preserved ones. They had to have been rapidly buried to get that kind of preservation. You get turtles and fish and actually marine creatures in that same deposit. What kind of creatures are found in there? In the Hell Creek Formation, the dominant one is Triceratops. That's the real common one. And then you got Tyrannosaurus is a close second. So the T-Rex, that's the home of the T-Rex there. And what do some of those fossils look like? The things are pickled in the rock. They're totally well preserved with skin. That's a piece of fossil dinosaur skin from Edmontosaurus. That's a mummified one. Notice you got more than just the bone preserved. You've got the soft tissue preserved as well. It's just a little snapshot of the Hell Creek Formation. And what do the bone collections look like? In one part of it, it looks like this. And that's actually a computer-generated image. Each bone was, believe it or not, this guy did some really precise work. Art Chadwick, he sent people out there and they collected GPS measurements on different parts of the bone so they could reconstruct the attitude of the bone in a computer program, and that's how they generated that plot. Anyway, that's fun and interesting to think about. The Hell Creek Formation, the Morrison Formation, these things are utterly catastrophic in their nature. Let's look at one from the Triassic. Let's go to the Shinle Formation. This is Ghost Ranch. And here you've got just a 1 foot thick layer of bones full of this one creature called Coelophysis. Almost exclusively that one creature. 1,000 individuals were excavated and several thousand remain, and about 1/4 of them are articulated. In other words, the skeleton is complete. There's no decay of bones, no scavenging, and the bones are current aligned, like they are at Dinosaur National Mine, like they are all around. They're current aligned. In other words, there was something, there's moving water involved. And, you know, it just looks like a tangled mess of bones. And I'm a terrible paleontologist. I say it looks like I'm a geologist. I say, tangled mess of bones. A paleontologist would scream at me. Yeah. Okay. And we have one of these. This is Coelophysis. We actually have one like that mounted in our museum wall. Thanks to J.D. Mitchell. We got a nice one there. And so you got to come and see some of this stuff if you want to see that thing. And we talk about that pose. They've also found marine creatures like this, or at least aquatic creatures like that one, strange looking things. But you know, that the layer in which Coelophysis is found in New Mexico is part of the same layer where the petrified forest is, not far away. A couple hundred miles away is the petrified forest. What is that? Was it a petrified forest? No, it was a petrified log mat. Those logs were transported in mud, volcanic-rich mud again. We see this theme again and again. Volcanic-rich mud is what buried those logs. And in those logs are also other kinds of creatures. We're talking about horrendous level of volcanism and water and mud that is responsible for most or a major part of the Mesozoic rock strata. And that's the Shinli Formation. Again, you got the same kind of weathered badlands look there. So the fossils include mammals, reptiles like turtles, lizards, dinosaurs, crocodiles, frogs, birds, sharks, coelacanth. All of them show up in this deposit. Most of the sharks, they appear to be marine creatures. And this guy says it takes a cataclysm to slam ocean onto land. That's Brian Thomas at ICR said that. Yeah. And horrendous volcanism on a giant scale. So we see that in the Triassic, Jurassic, Cretaceous, the major dinosaur beds. He says, I'm not picking at small bones here. These are the major sites where we get our information about dinosaurs. And we hear more about dinosaurs coming out of China. That illustration you're looking at there is a picture taken from a science journal, an artist's depiction of what happened to that particular dinosaur bed in China. And they say it was a porridge-like slurry of mud that buried those things catastrophically. And they got really well-preserved fossils over there as well. And I'm not going to get too far into it, but it's close to 5,000 meters thick. It's really thick, and it's mostly volcanic mud and pyroclastic flows, extremely violent deposit. And there you find all these kind of things buried together, lizards, birds, mammals, etc. Soft tissue abounding. It's been a history, it's also had a history of frauds. There's been some people who manufactured fossils over there. And the age date adjustments are driven by biostratigraphy, not evolution, or they're driven by evolutionary thinking, not by the data, because they've been adjusted and readjusted and changed. The geologists say, we report this age date, and the paleontologists say, no, that can't be right. You got to change that. We got to get a different date. Use a different method over here. And there's this picking and choosing of dating methods. It's not as objective as we're being told. Yeah, so porridge-like torrents of mud was responsible. That's the words of the scientific journal. So we've looked at some of these things: Dinosaur Country, Morrison Formation, Hell Creek, Shinli Formation, Yixian Formation in China. And I see a common theme in these things. I see lots and lots of mud of a volcanic nature. And I want to talk, just to give you a little word about mud, and then we're almost done. A word about mud. You know, mud is the sediment that gets no respect. And some of you remember late night television was actually humorous, and this guy was really funny. What's his name again? His name is, yeah, he was really funny. I got a kick out of him. He said, nobody gives me any respect, you know. He does this with his tie, you know. Anyway, yeah. But mud, let's think about mud for a minute. I want to give you just 3 points about mud that gets my attention. Now, nobody likes to talk about mud. That's the stuff you track into the house. And, you know, it's the same stuff that you don't like. But let's talk about mud for a minute. I think my writing is a little bit too small for you guys sitting in the back. Anyway, you know, it was not lava or pyroclastics that took out 25 bridges at Mount St. Helens, 200 homes, 185 miles of highway. It was mud. Torrents of that stuff spilled down the flanks of that volcano and choked the valleys around it. And objects that don't ordinarily float, including a 25-foot diameter boulder, was floated in mud that must have been more than 30 feet thick at the time. All right? Imagine rivers of wet concrete, and you have some kind of an image of what happened there in 1980. It was like porridge that went down that valley, and it just took out everything. Think of that when you think about dinosaurs, because I think that's the correct picture of what buried these things. Number 2, mud and dinosaurs. With very few exceptions, mud is the common factor in the foremost dinosaur sites worldwide. Mud, and not always, but frequently, it's volcanic mud. And the mud that stacked up logs, bridges, and cars at Mount St. Helens was probably the same mud that encases these dinosaur remains. Sudden death by drowning can be explained by the pistotonic pose, the blood clots inside the bone, apparently, and the evidence for rapid burial. Volcanoes on a super scale are needed to explain the fossil record. And one more point about mud. I call this mud madness. Mud is the dominant sediment. Now, you don't hear this too often, because who likes to talk about mud, right? Mud is the dominant sediment in the sedimentary rock record, making up about 70% of all the so-called sedimentary record, the rock record that we have, with all the fossils in it. And up until 2007, geologists were convinced that fine-grained sediment like mud, silt, and clay-sized material required extremely slow rates of settling, implying vast ages to accumulate this stuff. Today, it's confirmed in log flume experiments, field evidence, and fine sediments like mud can accumulate rates of centimeters per hour in fast-moving water. This probably doesn't mean much to you, but an entire paradigm was overturned. 70% of the sedimentary rock record now can be easily explained as rapidly deposited. You don't need millions of years to explain the mud rocks that make up a major part of the sedimentary rock record. And the so-called mud rock revolution is very much understated in the scientific community, but it should be of paramount importance to people who are interested in the flood and studying what kind of catastrophe happened to explain these things. And that's racetrack flume. That's some of the experimental apparatus. And the thing about mud is that they used to think it had to settle slowly and gradually. Today they know that's bunk. It can accumulate rapidly. I won't bore you with that. Common themes in the world's greatest dinosaur beds. These are the things that are rarely heard in public. All right, I'll give you just 7 of them. Explosive volcanism on an extreme scale. That's a common feature in these dinosaur beds. Number 2, a violent watery burial. Those bones were smashed into place along with the clams and the fish and the snails and the rest of it. Number 3, you got strange bedfellows. That's what I mean by the clams and so on. Number 4, everything is transported. Nothing is in situ. Everything was moved. Number 5, modern environments are meaningless. Haven't we had enough of the Jurassic Park imagery? Haven't we had enough of these storytelling about, well, this was a sluggish river. No, this was a floodplain. No, this was a levee break here. Oh, no, come on now. I think you're playing games here, right? Number 6, mud is everywhere in the sedimentary rock record. Number 7, the time scale problems abound in rock that ought to be fully datable. And how come we see this constant understatement of these truths? These are generalities I think you can take to the bank. And yet you never hear anybody talking about this. To me, it just, sometimes I want to jump up and scream when I hear young people being kind of persuaded into a view that is just distorted. Nothing appears slow and gradual. Everything is muddy, watery, catastrophic. Is this what we would expect from the flood? It is true that dinosaur fossils occur in the middle part of the sedimentary rock record called the Mesozoic. And it is true that human fossils are found only in the uppermost part of the sedimentary rock record. Why don't we see human remains buried with dinosaurs? This is a question young people always have, right? And isn't it true that if you have this kind of picture, isn't it true necessarily that dinosaurs lived in a prehistoric age millions of years before man? Isn't that really what the story is telling you? Only if you believe the geologists who tell you, well, we can confidently calibrate those layers in terms of millions of years for each layer. If you cannot do that, if you cannot give age dates on those layers that talk about millions of years, then where is the evidence that there was a prehistoric age? because the order in which creatures come and go on that sedimentary rock record may have nothing to do with prehistoric ages. It may have everything to do with the order in which creatures got buried as a result of a global flood. The Bible talks about a global flood. It talks in catastrophic terms about the flood. And so, did dinosaurs really live in a prehistoric age millions of years before the first man? If we don't give answers to kids on these kind of questions, even the little kids, the really small ones, as soon as they hear about dinosaurs, they hear about millions of years and they hear about prehistoric ages. And it goes into them, and sometimes the time bomb doesn't go off until they hit their teen years or their college years, and all of a sudden they realize, the Bible is kind of nonsense because it doesn't talk about prehistoric ages. And maybe I should discard the Bible because I kind of like my sinful lifestyle anyway, and I need a good excuse. And so I think we'll discard that one. And that's the way it happens. Dinosaurs are a major hook that draw kids away into an evolutionary worldview. If we don't give them good answers when they're young, it just goes into them. They just absorb this stuff. You got to stop them. I want to scream because the educators, they're telling kids this kind of stuff before they have the critical thinking ability to evaluate what they're being taught. They don't have the skills to do that yet. It's terrible. I really think I want to tell these educators, why don't you pick on someone your own size? So, towards a biblical interpretation of dinosaurs, number one, the rock record is not, these are the generalizations I got. The rock record is not what we've been told. Evolution, ages, I don't think so. I don't see that. I'm trying to be objective, and you can charge me with being a religious fanatic or whatever, but I think I'm being objective when I say that I don't see evolution, I don't see long ages in the rock record. Number two, humans and dinosaurs were both created in the beginning, and they were both created very good. This is what I believe. And during the same 6-day period, they must have been coexistent. Number three, both man and man's dominion, that is nature, the animal kingdom, were cursed at the time of the fall. And that's how come we have creatures with big fangs and big claws, and animal eating animal. And Adam's dominion was made to reflect, is what I believe, his own internal fallen condition at the time of the curse. Number four, if the dinosaur remains we see are from the flood, then either two of every kind went on the ark, two of every kind of dinosaur went on the ark, and that's, people laugh at that, and they say, is that really conceivable? Well, why couldn't he taken infant dinosaurs on the ark? In fact, he would be kind of stupid if he didn't, right? All right? But I think it's important to state that no land animal went extinct because of the flood. So one possibility is that dinosaurs were carried on the ark with them. The other possibility, I think, is a remote one, but I think it's possible that, they're finding more and more of these dinosaurs had a semi-aquatic lifestyle. They're finding it for more and more of these ones. Some are fully aquatic in recent years. And, it is true that, dinosaur bones are hollow on the inside. They're pneumatized. They got air pockets inside of them. In other words, the big sauropods would have bobbed like a cork in the flood. Could it be that some of them survived the flood? And could that explain some of the some of the trackways we see in the upper part of the sedimentary rock record? I don't know. That's just a possibility. It could help to explain some of the mysteries that I struggle with. They say that T-Rex was a real airhead. Have you ever heard that? That the T-Rex, he really would have floated because he had a lot of space inside that skull. Probably was a good swimmer, they say, about T-Rex. Number five, the order of creatures in the fossil record may have nothing to do with evolution, but everything to do with the order of burial. The fact that humans and dinosaurs are not buried in the same layer is no proof they lived in different ages. It just means they got buried in different layers. And we need to shout that one from the rooftop. And then number six, the accounts of dragons in historic literature and in the book of Job are too dinosaur-like and too ubiquitous to dismiss. So those are just some of my interpretations, my generalizations, my arm waving as a geologist who's not a dinosaur expert and who is kind of bored with a lot of dinosaur stories, but that's kind of my facts. So there we go. That's dinosaur graveyards. 7 facts not frequently heard in polite company. So there we go. That's it for me. And I'm happy to take some questions if you got them. And we're going to take a break. Okay.
Thank you.
Thank you.
Very good. And I'm glad to see we've had some young people here today.